Assalamu alaikum students, welcome to the unit of calculus. Today's topic is integration by parts. This is the second method after substitution method that helps us to find out the integrals of several functions. Before going to this very method, we must solve this very beautiful result. The result is beta, it is actually the theorem, and it says beta, if we have two functions fx and gx, but both these two functions are differentiable, then beta we have this thing, integral of fx g dash of x meaning differentiation of the second function dx, that is equal to beta fx first function into gx second function जो है हमारी g dash of x, तो उसका वो फंक्शन आती है वापस माइनस इंटीग्रल ऑफ द डिफरेंशिएशन ऑफ फर्स्ट फंक्शन f dash of x g dash of x gx dx. We have to prove this beta. So without wasting our time, we will go for proof. Beta, as you know that beta, this will result in differentiation, and then you differentiate beta that d by dx of f g, while these f and g are the functions of x, is equal to beta, the difference of the product of these two functions is equal to beta differentiation of first function and the second function plus first function into differentiation of second function. This is our most prominent result in differentiation beta. So we will apply this result here. As right now beta, we know that d by dx of fx gx is equal to f dash of x, then g of x plus f x g dash of. This is our most prominent result. I will take it as equation first now. After this setup beta, we will integrate this equation on both sides beta. We'll take integral on LHS and RHS both. So I will write here integrate on both sides. We get beta integral of d by dx f of x g of x dx is equal to beta integral of f dash of x g of x plus f of x g dash of x dx. So this will be equal to beta. Now we know that beta, this integral is actually the antiderivative of function. So beta here, differentiation and integration, they are inverse to each other, they will get cancelled. And we have also proved one theorem that beta, this d by dx, integral of d by dx f of x dx is equal to beta f of x. We have proved it beta. So here we will apply this. We will apply here. When we will cancel out this we will get here f of x g of x is equal to, now here is this integral of, we will separate these two now. Here it is f dash of x g of x dx plus integral of f of x g dash of x dx, which implies beta, here you check now, I need beta integral of fx g dash of x dx. So that means beta I need this integral. I will let this integral on RHS, but I will take this one to LHS. So when I will take this one to LHS, I will transpose it here. It will be now here f of x g of x. This is here plus, and when I will transpose it to the left side, it will get minus integral of f dash of x g of x dx. Now is equal to this integral, this one f of x g dash of x dx. Now I will write this integral first, and then I will write this to here. So I hope you have written this. After here I got beta this integral of fx g dash of x dx is equal to, I will write now this because I have written this, it is equal to beta this fx, and then this dx minus integral of this f dash of x g of x dx, g of x dx. Hence proved बेटा यही हमें प्रूव करना था, the integral of this very product is equal to the function f of x and the function g of x minus times the integral of derivative of f of x, derivative of fx, and the product of this g of x. Hence proved beta, this was our result. Now we will go to our method. Beta, we got till the time we got beta this f of x g of x dx, we got it equal to f of x g dash of x is equal to f of x g of x minus integral of f dash of x g of x. So this will help us to find out the method integration of parts. Now we will write down the note. नोट में क्या लिखोगे आप बेटा? We have this integral fx g of x dx is equal to f of x g of minus integral of f dash of x g of x dx. This is our integral. Now beta, I will put here put this f of x is equal to, for example, beta, I will take it u, and the g dash of x I will take as b. But this u, because we know that this f of x is a function, I have supposed this function in terms of u now, u of x or this, and g dash of x, it is again the function of x, and I have taken this function equal to v, where v is the function of in terms of x. Now beta, when I have f dash of f of x is equal to u, that means beta this, I need this thing, so that means beta this f dash of x dx, f dash of x dx. So beta, both sides we are taking this f of x is equal to u. So that means this is also in terms of x. So beta, I will differentiate it on both sides. When I will differentiate it, I will get beta f dash of x, then dx. But here I will get u dash of x dx. So it will be equal to du by dx. Now this is my first thing, and the second one beta, this g of x, I have derivative of g of x. Here I have function f of x. Now I found the derivative of this function. Here I have given the derivative of function. Now I will try to find out the function, and beta here I have differentiation here. I will, in order to get the function, I will integrate, because we know that the inverse of differentiation is actually the integration. So when I will integrate this function, I will get my gx. So integrate on both sides, I will get beta g of x is equal to v dx. So we can apply beta. Now putting these values to this condition first two. So we can apply from first two. I will get beta integral of what is f of x, that is equal to beta v u. Then I have g dash of x, that is equal to beta v, and then dx. So I'm getting here integral of u, product of two functions u and v. I'm getting it equal to beta f of x, what is that beta u, and then g of x, gx, what is that, integral of v dx. After that I have minus here, so I will write minus integral of f dash of x, what is that beta, du by dx. Du by, and that is beta the differential coefficient of first function, this u. And after that I have beta g of x, what is that, integral of v dx, and then this is then dx, and then. So what I am getting here beta, I am getting the integral of the product of two functions is equal to beta first function into integral of second function. You see here, integral of second function with respect to x minus integral of the differential coefficient of the first function, check, derivative of first function, and integral of second function. तो ये हमारा जो है ये वाला result है. This is actually the integral by parts. This method, this formula is called beta integration by parts. Yeah, integral. So integral by parts. This is the result. So what is happening in this result beta? I will write it in node. In this result beta, I am getting integral of the product of two functions is equal to beta integral of product of two functions is equal to first function into integral of second function minus integral of differential coefficient of first function into integral of second function. This I will write it on note better. I hope you have written this. Now I will write this rule better on. Right then, as remark बेटा यही रिमार्क में लिखवा हुआ आपको ये पता चला कहाँ से मिल गया रिमार्क. Integral of the product of two functions. Integral of the product of two functions is equal to first function into integral of second minus integral of बेटा फिर देखो ब्रैकेट में आप differential coefficient of first function into integral of second. This is our rule, and this last में लिखना. This rule is called integral by parts. Okay, you write on this. I have little work. Now we are getting here with a rule that gives us the integral of two functions when they are in product. So this is u and this is v. This is my first function, this is my second function, and I am getting it equal to first function. Yeah, I will write like this, minus integral of derivative by dx of first one into integral of second one. This is my rule, but if I will concentrate here on this rule, I have little bit of variation here. What is that variation, beta? I can have so many problems whether which function I will consider first and which one I will consider second. Beta, because it is possible for us here, this uv, we can write it also as vu, one factor one factor. That means beta if either u or v, if one factor of the product is a power of x. If one factor of the product is a power of x, अगर हमारे जो ये product है ये u and v, if we have one function from these two as the power of this x, that means beta x power something, x power 2 or x power 3, x power 4, so on. If we have like this, then beta power of x, then take this one which has the power of x, take it as first function. इसको लेना है आपको first function that point, but provided, because we know that in the rule we have to integrate the second function. We can suppose first function the power of x only if if we have the integral of second function, if the integral of second function exists. So power of x, take it as first function provided the integral of second factor exists. So this was my first beta. Now for you there is a one beautiful beta rule that you can follow while solving the integrals that are in product beta. That is beta, that very beautiful name is beta. Our rule is I L A T A. Means beta here this is our rule that you have to memorize beta, because with the help of this very word you can solve so many integrals. Beta, with the help of this you will consider the between two functions you will consider which one is first and which one is second. This is beta illate. The first function is beta, this I represents beta inverse trigonometry function. If we have product of two functions, we have to consider there the first function, that very function which is inverse trigonometric function. If we have two functions and between the two functions one is inverse trigonometric function, then we have to consider that inverse trigonometric function as first function. And second is beta L, that is beta logarithm. If we have two functions and between the two one is logarithm function, then we have to consider logarithm function as first function. And after that there is A, that is algebraic beta. If we have algebraic function beta, then this we have to take as beta first function. Algebraic function means beta, so the polynomial is this x square plus 3 square. If we have the function like this and another function someone else, then at that time beta third one we have to consider this first function, and next one we have to consider the second function. If that we have now trigonometric function, if we have now trigonometric function, trigonometric ratio beta, at that time we have to consider this as first function and the rest second function. Now the last one is exponent function. If we have exponent function, we can take there. This is our rule beta. It helps you beta to suppose suppose between two functions, the first and the second one. So first and foremost you have to give preference to inverse, and then if there is no inverse function, then you can give preference to logarithm function. If there is not any logarithm function, then you can give algebraic, and after that you can give trigonometric, and at last you can give the preference of exponent. This was the rule. Now I will solve some integrals and we will conclude this method after that. First one, beta, I is equal to x sine 2x. What we have, beta? I-L-A-T-E. So trigonometric function we have, before that we have algebraic function. So we have to, between these two we have to consider algebraic one first and the second, that is trigonometry, that is last one, that we have to consider second function. So this will be our first function and this will be our second function. We know, beta, that I is equal to, beta, what? First function, that is x, and then integral of second function, that is sine 2x dx, minus integral of derivative of first function, that is d by x, and then we have integral of second function, that is sine 2x and dx. It will be equal to, beta, x, and we know that what is the integral of sine 2x, that is minus cos 2x and divided by 2, and then we have this minus derivative of x, that is again x, but the integral of this sine 2x, that will be minus, that will become plus here, 1 divided by 2, integral of here, this one will get derivative x, that is 1, and integral of this is cos of 2x, because this 2 divided by 2 that we have already factor out. Now it will be minus x divided by 2, and then cos of 2x plus. Now here, beta, 1 divided by 2, we have integral of this cos 2x. What is that, beta? We know that integral of cos 2x, that is sine 2x, and this 2 will get divided, plus last में हम कहते हैं plus c. This is our answer, beta. You can now multiply here this 2 to this 2. You will get 1 divided by 4 sine 2x. You will do it by yourself. Now we will go for another example. Yes, beta, we will solve this. You will take the important example, beta, that is I is equal to tan inverse of three x minus x cube divided by 1 minus 3x. Why it is important, because in this integral we have to apply both methods, substitution method as well as this integral. This d x. You must be aware of the formula, beta. This tan 3x is equal to, beta, that is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. This is our, beta, formula of tan 3x. So we will try to make this as tan 3x. So here I will put, beta, here x as tan theta. Put x is equal to tan theta. Why I have substituted this x as tan theta? Because I have here tan inverse, and by the substitution of this tan theta I will get of the formula in terms of tan, and tan inverse and tan will get cancelled. I can put here lot of I can do lot of solutions here, but the best solution here is tan theta, because that will help me to get this as formula tan theta. So it will be, after that in the solution method we are taking derivative, dx is equal to the derivative of this tan theta, that is sec square theta d theta. After we are substituting these two, so which implies I is equal to tan inverse of what? 3x, what is 3? What is x? Tan of theta. Minus. Then x cube, what is that? Tan cube theta. After that we have divided by 1 minus 3x square, that means 3 tan square theta. Then dx we have sec square theta d theta. Now which implies I equals to this is tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square, that is equal to be tan 3 theta. I already told you it. And then we have sec square theta d theta. Now this tan inverse and this tan will get cancelled. I will get here I is equal to 3 integral of theta sec square d theta. Now I am getting the integral as a product of two functions. One is theta, that is bit of simple theta, that is algebraic, and the second one is trigonometric. And we know that we have to suppose first function as algebraic. So we will take this first function, and this one we will take second function. And we know that when we are going to solve the product, the integral of the product of two functions, we are here 3 here. We have to do beta first. We have to keep first function as same, and then we have to integrate second function sec square theta d theta. After that beta we have to subtract the minus integral of derivative of first one, that is beta d by d theta theta, and then integral of second one, that is sec square theta d theta and d theta. After this beta it will be equal to, now I is equal to 3 and then theta. What is the integral of sec square theta? That is beta tan theta. So we have this formula as tan theta, and then we have minus integral of d by d theta. What is the derivative of theta? That is 1. What is the integral of this sec square theta? That is tan theta under tan theta, and then we have d theta. So after here we are done. We got beta I is equal to 3, then theta tan theta minus integral of tan theta d theta, which implies beta I is equal to 3, we will multiply theta tan theta minus, what is our the integral of this tan theta. We know that the integral of tan theta is equal to log of what, sec theta. So here it will be log of sec theta plus c. Now you can have two solutions of it. One solution that is present in your book, and the second solution you can make here by giving the value of theta back. But if you want to have the solution that is present in your book, then I will definitely give that solution. Here I will take your solution better, the solution that is in your book. But here it will be 3 theta tan theta. We know that beta log m log n is equal to log of n raised per m. Here it is -1 beta, it will go opposite, it will be here plus log of this minus m, just like this, it will be here sec theta -1 plus c. It will become I is equal to 3 theta tan theta plus log of inverse of sec theta, that is cos. We write cos theta plus c. Now we will give the value of theta back. We have beta x is equal to tan theta. When we will multiply on both sides by tan inverse, we will get here tan inverse x is equal to theta beta. So here it will be 3 tan inverse x into tan theta, that is tan inverse x, and then we have plus log of cos of theta, that is tan inverse x plus c. This is further equal to tan and tan inverse, they will get cancelled. 3x tan inverse x plus log of cos of tan inverse x plus c. This is your answer. Okay, we will go for another example. Yes, beta. This will be our last example, and it will end the method integration by part. Now we have, if we have this I equals to x sine inverse of x dx. Because of this late, the first function we have to consider beta what? This inverse, because inverse, this sine inverse, so we have to take this as first function and this one as second function, and you will get I is equal to first function, we have to write it as this sine inverse x, and then we have to integrate the second one, that is this, and it will become x squared divided by 2 minus the derivative of the first function, that will be 1 and the derivative 1 divided by under root of 1 minus x squared, and then the integral of this, that is x, and then the integral of this x squared divided by 2. This square and this will get cancelled. You will get here I is equal to sine inverse x into x square divided by 2 minus 1 divided by 2 integral of x divided by 1 minus x square dx. Now here it is easy beta. You can put this 1 minus x square to t square, you will get there 2x dx to this. You will put here, put 1 minus x square is equal to t square 1 x square to t square. This this one I will take it as u in u. So you will get rid of minus 2x dx is equal to 2t dt. This one will get this cancel. So I will get here I is equal to sine inverse of x into x square divided by 2 minus 1 divided by 2, and then x dx that is minus t dt, and then divided by under root this cos square that is t, and this t will get cancelled to this t. I am getting here I is equal to sine inverse of x square divided by 2 minus 1 divided by 2 minus d that is beta minus t, and that will be t plus c. Now I will give the value of t back, that is x square divided by 2 sine inverse of x plus 1 divided by 2 t. What is t beta? That is under root of 1 minus x square is plus c. This is my answer beta. You can solve this rational interval by this. And tomorrow in Sulavrama we are going to solve two most important results or two most important integrals, and after that beta we will let this unit let this method complete, and after that we will go for definite integrals. This is enough now.